Hello YouTube, it's been a long time, so let's just jump right into it. In the last video we looked at move generation, and I think I said that we were fully done, but actually we have made an implementation of all these functions, and for the knight, the bishop, the rook, the queen and the king, it should be done. But one thing we forgot to look at was the promotion moves for the pawns. So we need to consider that somehow. Oops. And let's see. I jumped away from it somehow. Okay. So basically we need to do something like this, but then we need to instead promote the piece and not just move it. So actually there's probably a bug somewhere in here where one of the new squares will be like on the last row, and then we will try to move it there. So let's see, let's make a test that's failing just to illustrate. Test promote single pawn, and we'll start by making a game and adding a single pawn on e7, let's say, and then we want to generate the moves for the game, and there should be one for each possible promotion, and we can have we can promote to a queen, to a knight, to a bishop and to a rook. So there should be 4. Let's try to run that. Okay, here we go. And it failed on promote single pawn. And why did it fail? Panicked at the king was missing. What is that? I forgot what that is. Line 129. Ah, that's interesting. Okay, let's just bypass this one and let's say generate pawn moves and do like that. And we need the piece. There we go. Okay. What am I looking at here? Oops, this was the wrong one, the wrong test I was fixing. Okay, it was this one. And game, let's run it. Yeah, so it is generating only one move, one potential position, but it should be generating it for where you promote. So it's a bit of kind of annoying logic we have to implement. And we could implement it here, or we could implement it in here, in the move piece. So let's take a look at that one, because I think, not that one, I think it's already quite complicated, so I don't really want to do more things in here if I can avoid it. So let's do it here. Actually, let's before we do anything, let's make sure it doesn't happen here. So how do we do that? Okay, this is where we take another piece, and this is where we move 2, and this is where we move 1. So let's do something like this. I don't know how nice this is, but if you're white, then the last row is 7. If you're black, the last row is 2. And we will say here, and if the row is not equal to the last row. So that should mean that we don't generate any moves in the single pawn. Yes, now we generate 0 moves. Should be 4. And then here we will handle the specific case where we are on the last row. And now we can even do this. And then we can say something like, I guess we kind of need to do it down here, where we already have the positions vector, and then we will say new we will say something like this. New position, perform promotion, promote, okay. And let's see again, we need to somehow find out which is the square it's trying to promote on and which it's coming from. So let's do it like this. The square, where's the square defined? It's only defined here. Okay, never mind. Okay, so we need the index of the position. So we'll just say position is, wasn't there a function for that? Yeah, it's just called index. So we can say index row column. Row column should be valid here. Then we will give that. And we will push it. Great, so now we need to implement that. Let's go into position and go down here. Let's put it under take en passant. So, mutable self. We can actually do it like this, I've learned. And we need the piece position. Which is a piece position, I guess. And then we need Why do we have the position twice, you might ask? Very good question. And that should be it. Let me check I'm not forgetting anything. Okay, it has the new position as well. Yeah, sure. Let's. Why not? Let's add that. And we can unwrap it. Okay, great. So now we kind of need to do the same sort of things that we're doing up here. So I think I will do that off screen. And with the power of editing, it will seem like just a moment. Okay, so I realized a couple of things. First of all, we should provide the thing we want to promote into. And it can be a queen, a bishop, a knight, or a rook. So I've added that. And also in move generation, the thing we should put in here is not the index, but it's the bitboard. At least if we use piece position type, as we do up here. Actually, it looks like it's not necessary, so we can instead call it new index, and then it will just be a U size. We can remove it here, go back here, do like this. And that should still be good. No, I didn't like that. What did it say? Because we still need to assign it here, so okay, we will need it anyway. Now I'll just put it here. Okay, so now we need to do these things, and basically we want to do the same things in all of these cases, but let's just see how it works for the queen. So first of all, we want to make a new piece actually. So like promoted queen is equal to a piece, and then we have to remember how the piece type looks. So it needs a position, which is now we need the new position again. So maybe it was not such a good idea to remove it. So it needs a position, which is the new position. It needs a color, which is the color of the current piece. So let's see. Let's just get the current piece. And also this is wrong, actually. Let me put it to do. Delete the pawn. But anyway, so the color is the current piece. Dot color. The piece type will be the queen. And and alive will be true. And again, we don't actually want to delete, we want to kill the pawn. Okay, so now that we have a piece, we want to add the piece on the new square. So we want to, first of all, push the piece, so it's in the piece list. And then we want to say square squares on the new index, sorry, that should now be occupied by the piece at this index. Right. And then we need to do that again. And probably we should could write a small function. We could also write a small macro. Call it promote, and it will take simply a piece type, which we will say it's an expression, and then it will do all of this. Maybe it's okay to put it like that. Right, and instead of the queen, it will be the type, and we can call it piece here instead of queen. Piece, that should be okay, that should be okay. And then here we can say promote a queen. Same here. I don't think this will work though. Let's try. Yeah. So what we need to do is just, not this one, this file, to wrap this in a block. And that should be enough. Oops. Okay, it still doesn't like this, so we can just do this up here. Expected identifier, then let's just call it an identifier. Will that work? Yes. Okay. And now we need to kill the pawn. So we need to say that this piece is no longer alive. All right. And now let's check the move generation. Run the test. The test failed, which is also correct because you can see here we're only promoting a queen. So can we do something like for type in, and then I want to write this, but I'm pretty sure this will not work. Promote that type. Yeah. Can try to make it an array. Let's see if that works. Worked. It still failed. Try to move a piece from an empty square. That's very interesting. Let's see here. Promote. Perform promotion. It's panicking over here. And I see why now. I think I see why. Because we actually need to move all of this into the loop here. And now it works. All right. That's great. Let's just, as a final thing, make a few more tests. All right, let's expand this test. So let's say for position and positions, then we should still only have one piece. And let's say allow types, queen, bishop, knight, and rook. And then we will say that the piece type is contained by this array. Okay. That worked. Let's run it. Okay, very interesting. Okay, so probably it's because of this. Because we have two pieces, just that one is dead. Did we have some kind of counting function here? Like count. We have something called a live count. But we don't have a function for that. Right? Alive. Yeah, we have nothing called count. So let's make a function like that. What am I doing? Implement position. And let's put it after all the initialization. So we will say count pieces. Sure. And it only needs a reference. And it should return, I don't know, usize. That should do it. And then here we can just say, actually just count the pieces, and there should only be one. There we go. Still failed. Interesting. It's saying it has a because the queen will be piece number 1 and not 0. Okay, now it's working. Let's say that's it for this time. And then next time, now we are really done with the move generation code. Next time we need to try to generate a bunch of positions, generate the positions after that, and so on, count how many we get, and check it against some like accepted reference numbers to see if the full implementation is correct, just as an extra correctness check. See you next time.